Welcome everyone to Makaut Electrical Engineering channel. So the next most important question is Savart's law. So the Savart's law states that the magnetic field due to current carrying element IDL is directly proportional to point 1 to which directly proportional to it. So this magnetic field is due to some current carrying element. Obviously we know that if current is flowing from particular element, for example this is a wire, okay, so if current is flowing through this wire, it will produce some magnetic field around it, isn't it? So this magnetic field, okay, dB is noted as dB, okay, is directly proportional to some of the factors which we are discussing here. So it is directly proportional to the strength of the current, okay, to the strength of the current. So there is some current, isn't it, I, so it is directly proportional to the current I. Then it is directly proportional to the sine angle, it is directly proportional to some sine angle, for example theta. For example, there is like this, there is one element, okay, and some current is flowing through this element, so the angle formed, isn't it, there's some angle formed, for example theta angle is formed, okay. So this theta angle, this magnetic field will also depend on this theta angle, okay. Next it will depend on it is directly proportional to the length of the element, isn't it, the length of the element, that is nothing but denoted as dl. We can write it as L also, okay, we can write it as L, but we want to denote it, okay, we can find expressions, we can find derivatives, so it is better to write it as dl, okay, that is why it is denoted as dl, as a derivative form, okay. Next, it is inversely proportional to square of distance, this distance is denoted as r. So what does this force statement means? This force statement means, for example, we have one conductor, okay, for consider this as a conductor, its length is AB, for example a conductor is there, AB conductor is there, okay, some current carrying element is there, for example this is a wire current carrying element, okay. So this element is carrying some current, for example I, okay. Consider one random space point, orbital point or random space, we will consider a point random space, okay, I am considering this point, for example P, okay, in space. Then from this point, okay, from this center of this conductor to this point P, okay, we'll draw one line, okay, to denote, because we know that it is proportional to the strength of the current. It depends on your current I, then it depends on the angle theta, it's depends on your length, and it depends on your distance, square of distance, okay. So for example this point to this point, take this distance as r, take this angle as theta. So what do we know? It is directly proportional to the current I, distance dl, length, isn't it, and your angle, directly proportional, na? And it is inversely proportional to distance. What distance? Square of distance, that is by r square. Now when we remove this proportionality constant, or when we remove the directly proportional constant, we have to introduce one constant here, okay. So this dB turns out to be k idl sine theta by r square. To remove this direct proportional sign, we have to introduce one constant k. Now this k has some value that is denoted as k is equal to mu naught by 4 pi. So we can write this expression as dB is equal to mu naught by 4 pi idl sine theta by r square. So this is your expression for Savart's law, okay.